Hello, thank you for joining us. Module 2B Day 2, where we're going to focus on arithmetic sequences, their partials, and their partial sums. So looking at our notes for arithmetic sequences and what we'll call partial sums. So what is an arithmetic sequence? An arithmetic sequence, or a sequence rather, is arithmetic if the differences between consecutive terms are the same. So we'll say that we have a common difference. So this sequence, a sub 1, a sub 2, a sub 3 to a sub n, going on infinitely, is arithmetic if there is some number d such that the difference between the first two terms is the difference between the next two terms, right? And that difference continues on between two terms, that if that difference is the same each time, then we'll say the sequence is arithmetic. Right? And we have a formula that gives us the nth term of an arithmetic sequence, right? And that formula is nothing more than saying that if I take my first term and I add my difference n minus 1 times, that'll give me my nth term. So for example, if I wanted to get my fifth term, that'll be my first term plus 4 times my common difference. Okay? The sum of an arithmetic sequence, right? If I wanted to find the sum, this is what it's going to be given by, right? And I can think about it as 1/2 the number of terms, so half of the number of terms times the sum of the first and the last terms. All right, so very, very useful formula to know and to be aware of. All right, for our notes here, we're going to be using a calculator. I like to use the NumWorks calculator for its functionality. If you're using a different technology, make sure you understand how to use your particular technology. All right, so if I want to write the formula for the nth term of an arithmetic sequence whose common difference is 5 and first term is -1, I can just say, hey, u sub n is going to be 5n minus 6. Now, how did I get that? Well, I know that the 5n is going to be related to my common difference, right? So if I have a common difference of 5, that means I'm adding 5 each time, and repeated addition is multiplication. But then I need u sub 1 to be -1, and that's going to be 5 times 1 minus 6. So I got to figure out what is going to be that number that makes my formula work. Okay. If I want the formula for the nth term of the sequence given by here, well, we need to figure out what's happening between each term. And it looks to be that each time I am adding 4. So my formula, I could say u sub n is going to be 4n, and then I need to have -3 if n is equal to 1. So if u sub 1 is going to be 4n minus something so that I can get to -3. And we say, well, 4 minus what gets me to -3? That'd be 4 minus 7. So u sub n is going to be 4n minus 7. Okay. If I want the fourth term, or rather if I'm given the fourth term of an arithmetic sequence is 20 and the 13th term is 65, and I want to figure out the first 5 terms of the sequence, that's going to be important to be able to figure out what the nth term is. Right? Well, how can I do that? One way is to recognize that the 13th term minus the fourth term is going to be 65 minus 20. Right? So if I come over to my calculator and I say 65 minus 20, or even without, I get that that's going to be 45. So what does that mean? Well, I know that my 13th term will be my fourth term, right, plus 45. I also know that 45 has to be my common difference multiplied a certain number of times. Well, how many times am I going to multiply it? Am I going to add my common difference to get from my fourth term to my 13th term? Well, I'm going to add it 9 times. all right, because from 4 to the 5th term is going to be add once, 4th to the 6th term is going to be add twice. So this tells me that my common difference is 5, and that tells me that a sub n is going to be 5 times n, right? And then I've got to figure out what my constant is going to be to get me to my first term. Well, I can figure out my first term by considering my fourth term and subtracting my common difference 3 times. Because if I subtract my common difference once, it gets me to the third term, twice gets me to the second term, 3 times gets me to the first term. So what does that mean for me? That means for me the following, that a sub 1 is going to be equal to my fourth term, 20, minus 15, which is 5. Right? That means then that my constant is 0 and that my a sub n term is going to be 5. But that's not what I'm asked to do. I'm asked to figure out the first 5 terms of my sequence. So my first 5 terms are going to be 5, 10, 15, 20, and 25. All right? So I'm essentially just counting in 5s with a common difference of 5. Determine the number of terms if in the sequence, and I'm given this sequence. Once again, let's look for our pattern. It looks to be that I am subtracting 3 each time, and my last number is negative 101. So my nth term, which is negative 101, is going to be my first term, 4, plus my common difference. All right, so plus n minus 1 times my common difference, and my common difference happened to be negative 3. Okay, if I subtract 4 from both sides, negative 105 is going to be negative 3 times n minus 1. All right, so then let's divide, and I have 105 divided by 3 in net effect. So that means that 35 is equal to n minus 1. So therefore I have 36 terms in my sequence. I can double check that by saying 4 plus 35 times negative 3, and that should give me 101 on the negative side. So how many terms? I can work through to determine the value using my formula for the nth term of an arithmetic sequence, which I have right there. Okay. Continuing, if I want to write a formula for the sum of my given terms, if I want to write a formula for the sum of my given terms, right, and it's going to be 2-digit positive numbers ending in 4, well, I need to think about what this is going to represent. So 2-digit numbers ending in 4. The first one will be 14, then I'm going to have 24, then I'm going to have 34, and I'm going to go all the way till I get to 94. After that, I don't have 2-digit numbers anymore. So that means that my first term is 14, my nth term is 94. How many terms would I have? Well, I'm adding 10 each time, so I would have a total of 9 terms. And my general formula is that the sum of the first n terms is my number of terms divided by 2 multiplied by my first term plus my nth term. Substituting in, all right, I have 9 terms, right? 9 over 2, the first term is 14, the last term is 94. It just asks me to write a formula for the sum, and so there is my formula for the sum. Okay. That's it for this first part of the video, introducing the arithmetic sequences and their summations or their partial sums. We'll continue with some applications in our next video.